So it turns out that a massive underwater whirlpool, yes, an actual swirling vortex, was recently captured by satellite imaging, and it's not where you'd expect it. Not near some tropical cyclone hotspot or in a typhoon-churned sea. No, this thing appeared just off the southeastern coast of Madagascar, spinning silently beneath the surface of the Indian Ocean. You wouldn't have even known it was there if not for the latest readings from a French oceanographic satellite called Jason 3, designed to track sea surface height and temperature variations. That's when researchers noticed something strange, a huge, circular pattern about 100 miles wide, rotating counterclockwise, subtly tugging at nearby currents like a hidden planetary gear shifting everything around it. Now, here's the thing, whirlpools in the ocean aren't new. Scientists have studied smaller ones for decades. They usually form from eddies, these spinning pockets of water created by currents, tides, and wind. But this one wasn't just any eddy. This was an anticyclonic ring, the kind that builds energy over time and has enough inertia to persist for months, sometimes even a year or more. These things can suck in heat, microplastics, fish larvae, you name it, and carry them thousands of miles across the ocean like a hidden conveyor belt. But what makes this whirlpool so bizarre is its size, its depth, and, most alarmingly, its trajectory. Most ocean eddies kind of meander in place. They swirl for a while, spin themselves out, maybe bounce off some other current or coastline and dissipate. But this one? This one is moving. According to simulations run by the National Oceanic and Atmospheric Administration, the vortex is currently drifting southwest, nudging closer to the Mozambique Channel. That's a problem, because the channel is one of the most dynamic marine corridors in the world. It's already teeming with competing currents, upwelling zones, and unpredictable underwater topography. If the whirlpool continues on its current path, it could cause massive disruptions to marine migration routes, local fisheries, and even regional climate behavior. But hold on, it gets weirder. When researchers looked closer at the satellite data, they noticed that this whirlpool wasn't just a surface event. Using altimetry readings and data from underwater autonomous gliders, they realized that this spiral reached downward for over 3,000 feet, forming a kind of inverted cone of spinning seawater. Picture a funnel, not above you like in a tornado, but beneath you, invisible unless you're tracking tiny shifts in water density and temperature. And as it spins, it gathers strength, feeding off the difference in salinity between surface rainwater and the deeper, colder Atlantic origin currents pushing up from the south. That combination of heat, salt, and movement is exactly what gives rise to thermohaline anomalies, oceanic disruptions that can mess with weather systems hundreds of miles away. This whirlpool might seem like a local event, but its implications go far beyond that. In 1997, a similar phenomenon was recorded off the coast of Brazil, a hidden eddy over 80 miles wide that trapped fish populations in a tight spiral, essentially creating a marine desert within its borders. Fishermen were confused for weeks. Fish stocks disappeared. Coastal weather got erratic. But back then, we didn't have the satellite precision to map what was going on beneath the waves. Today, with high-res infrared satellite sensors and autonomous gliders that dive and resurface every 8 hours, we can see it in shocking clarity. And what we're seeing right now in the Madagascar vortex has oceanographers worried. It's not just spinning water. It's a mass transport system, a kind of marine Ferris wheel, except it's the size of a small country and loaded with cargo we can't control. Inside the vortex, researchers have detected anomalously high levels of carbon, possibly absorbed from nearby upwelling zones rich in decaying organic matter. That's fine in small doses. But this whirlpool is concentrating it. Think of it like a centrifuge. As it spins, it separates and collects materials that would normally be spread thin across hundreds of miles. Scientists fear that if the vortex breaks down suddenly, say, by colliding with the strong south equatorial current, it could release a concentrated carbon plume into shallow coastal zones. That could have serious implications for coral reef ecosystems, many of which are already teetering on collapse from acidification and warming. Let's take this one step further. There's also a theory, one that's more speculative, but too intriguing to ignore, that these mega-eddies might have some link to undersea seismic activity. Yeah, you heard that right. In 2011, researchers noticed that a chain of eddies in the western Pacific seemed to coincide with an increase in microquakes near the Tonga Trench. Nobody knows if there's a causal relationship, or if it's just coincidence, but some ocean physicists have started wondering whether the energy redistribution from these giant whirlpools could, in some way, affect pressure zones in the oceanic crust. Because here's something crazy. The Madagascar vortex appeared less than a week after an unusual deep-sea tremor was registered about 200 miles off the coast of Réunion Island. It wasn't a typical earthquake. It was what seismologists call a slow slip event. No shaking on the surface. No tsunami. Just a deep, glacial movement of tectonic plates, like the Earth exhaling after holding its breath for too long. And that's what makes people nervous. Because if this whirlpool is somehow interacting with geological forces, or even just responding to them, it could mean that our oceans are far more dynamic and interconnected with Earth's interior than we ever realized. And then there's the issue of direction. As of now, models project that the vortex will graze the coastline of Mozambique and then shift course toward the southwest Indian Ridge, a massive underwater mountain range. That area is known for bizarre magnetic anomalies and unexplained sonar reflections, some of which were recorded as far back as the 1960s by Cold War submarines. If the whirlpool reaches this zone, no one knows what will happen. Some marine geologists speculate it could get caught in a loop between submerged seamounts, creating a stationary gyre that traps marine debris and disturbs nutrient flow across the region. Others worry it could collapse entirely, creating rogue waves on the surface or sudden changes in ocean stratification, which could alter weather systems from Madagascar all the way to the Horn of Africa. And while that might sound like science fiction, remember, until 1992, we didn't even know underwater rogue waves were real. Ships would report being hit by 80-foot monsters in calm seas, and no one believed them. Now we know that pressure interactions and wave groupings can create those very anomalies. So what if these massive underwater whirlpools are just another piece of that puzzle? One thing's for sure, whatever this thing is, it's not done yet. And the question everyone is now asking is this: where is it heading next? Before we continue, please consider subscribing to the channel for more nature updates like this. Your support means a lot to us. Let's start unraveling this strange aquatic phenomenon by diving deep into the first major reason scientists believe could be behind the sudden and powerful formation of this massive underwater whirlpool, an unusually intense oceanic eddy caused by drastic shifts in thermohaline circulation. Now, that might sound like jargon, but the idea is fairly simple, and wildly interesting once you realize the implications. Thermohaline circulation, sometimes called the global conveyor belt, is the vast, slow-moving system of deep ocean currents driven by differences in water temperature, thermo, and salinity, haline. These variations affect water density, which in turn creates motion as lighter waters rise and heavier waters sink. This process governs how heat is distributed across the planet, playing a crucial role in everything from the mild winters of Western Europe to the intensity of monsoons in Asia. But when this conveyor belt is disrupted, even slightly, it can trigger a ripple effect that leads to massive consequences in localized regions. What researchers are now starting to believe is that such a disruption could have given birth to the enormous whirlpool that was caught spinning in the satellite image. The basic mechanism works like this. In the open ocean, especially in regions like the South Atlantic, warm salty water flows northward on the surface while cold, less salty water sinks and flows southward beneath it. When this flow is altered, say, by sudden fresh water input from melting ice sheets or unusual wind patterns, it creates an imbalance in water density across large stretches of the sea. This imbalance doesn't just go away quietly. Instead, it churns, twists, and spirals. That's how eddies form. Most of the time, they're relatively harmless, maybe 100 kilometers wide, lasting for a few weeks, moving slowly with the currents. But occasionally, under the right conditions, they can grow. And grow. And that might be exactly what happened here. The whirlpool spotted from orbit isn't your garden variety eddy. It's massive, So large, in fact, that early size estimates suggest it spans more than 400 kilometers across, roughly the distance from New York City to Washington, D.C. To reach that scale, something would have to have supercharged the usual eddy formation process. The most probable suspect? A sudden and extreme influx of fresh water from Greenland's rapidly melting ice sheets. Satellite data collected over the past 2 years already shows accelerated melt rates in the Arctic, but what really caught experts off guard was the timing. Just as the whirlpool began to emerge, a series of warm atmospheric rivers had swept across the North Atlantic, unleashing unseasonal warmth on Greenland's ice cap. The result was a deluge of fresh water, billions of gallons, dumping into the surrounding sea in a matter of weeks. Now, here's the kicker: fresh water is less dense than salty seawater. When enough of it floods into the ocean, it disrupts the density gradients that keep thermohaline circulation steady. That imbalance causes the water layers to become unstable, like a shaken bottle of oil and vinegar. And when such turbulence happens at scale, it doesn't settle evenly. It spirals. It warps into looping gyres. It mutates into massive, rotating currents that sink, lift, and spin everything in their vicinity. In some areas, this forms a vortex so powerful it can be detected from space. That's likely what we're witnessing here: a thermohaline anomaly grown so large it turned into a visible, measurable behemoth churning just beneath the ocean's surface. And the thing is, it wouldn't be the first time we've seen the ocean act this way. In 2003, off the coast of Brazil, a similarly enormous eddy was spotted by NASA satellites. It wasn't quite as large, and it didn't gain much public attention, but to oceanographers, it was a warning shot. That eddy, dubbed a monster vortex at the time, formed unexpectedly and remained active for over 3 months, disrupting marine life and causing measurable shifts in sea surface temperatures in the region. What's happening now, however, seems even more extreme, potentially far more persistent, and its location is even more unsettling. This time, the whirlpool isn't forming in a relatively isolated part of the Atlantic. It's heading straight toward regions critical to global ocean mixing, like the Labrador Sea or even the Erminger Current near Iceland. That's where the unease starts creeping in. If this whirlpool continues to spiral with increasing force and shifts into one of those crucial ocean mixing zones, it could cause major disruptions in global ocean currents. Think of it like a kink in a garden hose. The water still flows, but with pressure, turbulence, and possibly explosive backflow. We're not just talking about rougher seas or strange weather. This could alter the marine migration patterns of whales and fish, upend delicate coral ecosystems, and even impact the air temperatures of entire coastal regions. And it all comes back to this one chaotic swirl, this one defiant spiral, feeding off the fractured thermohaline highway that's supposed to regulate the planet's climate systems. Now, while the disruption in thermohaline circulation stands out as one of the leading culprits behind this bizarre and massive oceanic whirlpool, it's not the only theory that has scientists scratching their heads and poring over satellite data around the clock. As research teams continue to analyze this aquatic anomaly, another equally compelling and deeply concerning explanation has started gaining traction, one rooted not in ocean chemistry, but in the planet's geological heartbeat. We're talking about tectonic activity, and more specifically, unusual submarine volcanic movements that may be brewing beneath the surface, largely undetected by traditional seismic instruments. The connection might not seem obvious at first glance. After all, we usually associate volcanic eruptions with plumes of ash rising from mountaintops, or lava flows cutting through forested land. But deep under the ocean floor, there exists an entirely different kind of volcanic landscape, one that stretches across tens of thousands of kilometers. It's called the Mid-Atlantic Ridge, and it's essentially a gigantic underwater mountain chain formed by the slow, steady pulling apart of the Earth's tectonic plates. For the most part, this geological process happens quietly, releasing magma in small, manageable amounts. But every so often, something shifts, something powerful. And when that shift happens, it can trigger events that ripple not just through the seafloor, but up through the water column, distorting currents, altering temperature gradients, and even causing whirlpool-like disturbances. What researchers are beginning to suspect is that we may be witnessing such an event right now, an undersea volcanic disturbance so intense that it's displacing water at a scale large enough to create a rotating system of currents. It's a theory that seemed fringe at first. But then, something curious happened. Several underwater hydrophones, specialized listening devices anchored to the seafloor, picked up low-frequency rumbling sounds in the days leading up to the Whirlpool's formation. These weren't the sharp cracks typically associated with earthquakes. Instead, they were long, sustained, almost mechanical vibrations, what geologists sometimes call harmonic tremors. And harmonic tremors are almost always tied to volcanic activity, specifically the movement of magma beneath the Earth's crust. Now, if this is indeed what's happening, if a hidden volcanic system beneath the ocean floor is coming alive, then it stands to reason that the sheer force of that geological motion could be enough to push massive volumes of water upward and outward, initiating a swirling, spiral motion in the surrounding ocean. Imagine a pot of water on a stove beginning to boil, not violently, but with that first slow roll, where bubbles push from the bottom and twist the liquid above. Scale that up by a few million times, and you start to understand how something as deep and invisible as magma movement could create visible surface phenomena large enough to be caught by satellites. And here's where it gets even more unsettling, because this wouldn't be the first time that underwater volcanic activity has led to strange oceanic behavior. In 2012, a previously unknown submarine volcano erupted off the coast of El Hierro in the Canary Islands. It didn't make global headlines, but for months, the surrounding sea turned discolored, fish washed ashore, and strange eddies formed near the surface. Those events were on a much smaller scale, and yet they caused weeks of ecological and navigational disruption. What we're potentially seeing now, in contrast, is that same process, but on an exponentially larger level, possibly even a once-in-a-century geological event. The Whirlpool could be the first visible clue of something far deeper and more powerful stirring beneath the seafloor. And this brings up another eerie detail. In the region where the Whirlpool formed, satellite imagery has begun to show subtle discolorations, minor, but present, hinting at possible mineral or gas discharge from below. Some analysts have even suggested the faint possibility of a hydrothermal plume, superheated water rich with volcanic gases and minerals, rising up through the ocean and destabilizing its layers. If confirmed, this would all but seal the case for submarine volcanic activity being a major factor here. Because when heat from beneath the Earth is injected into the ocean in such large quantities, it changes the local temperature, density, and current patterns almost instantly. That sudden influx of energy causes water to rise, fall, and swirl in unpredictable ways, creating the perfect conditions for the kind of colossal whirlpool we're now witnessing. Of course, the challenge lies in confirming this theory. Unlike land-based volcanoes, undersea eruptions are notoriously difficult to monitor in real time. The ocean is vast, and much of its floor remains unmapped and unobserved. But the pieces seem to be aligning: seismic whispers, temperature anomalies, unexplained mineral traces, and now a giant whirlpool that refuses to behave like anything we've seen before. Scientists are starting to connect the dots, and the picture that's emerging suggests that something profound may be happening beneath the waves. In short, what began as an isolated atmospheric curiosity is now morphing into a full-blown geological mystery. The ocean, it seems, isn't just reacting to the sky or the wind or the melt of distant glaciers. It might be responding to the slow, thunderous breath of the Earth itself, rising, rumbling, and spiraling outward in a way that demands to be seen, studied, and understood. If we continue to peel back the layers of this extraordinary phenomenon, a deeper, more complex picture starts to take shape, one that suggests the whirlpool may not simply be the result of a singular, sudden volcanic event, but rather the byproduct of a slow, long-term awakening happening deep beneath the seabed. What's particularly compelling to researchers now is the possibility that what we're observing isn't just the surface signature of a localized eruption, but part of a broader pattern of tectonic unrest that's been quietly building over time. Geological sensors placed along the Mid-Atlantic ridge have, in recent years, recorded subtle increases in heat flux, tiny, incremental upticks in geothermal energy escaping from beneath the crust. These shifts have been so gradual that they didn't initially trigger much concern. But in hindsight, they appear to form a timeline of slow escalation, a creeping geological pressure that has only recently culminated in the violent churning motion now visible from orbit. It's like watching steam build inside a sealed pressure cooker. There's no chaos at first, just rising tension, until one day, the pressure finds a release point. And in this case, that release might have taken the form of vertical water displacement strong enough to twist the surrounding currents into an enormous, self-sustaining gyre. More intriguingly, recent oceanographic surveys, some conducted using autonomous underwater drones, have revealed unexpected terrain deformations in the region near the Whirlpool. These aren't large rift valleys or classic volcanic cones, but rather odd-mounted structures, like blisters on the ocean floor. These formations, known as pillow lavas, are created when magma seeps slowly into cold seawater and rapidly cools, forming bulbous lava deposits. The presence of such structures indicates that magma has likely been extruding quietly for some time, possibly for months or even years, well below the detection range of conventional systems. This suggests a long-term buildup of geological energy, one that may only now be breaching the surface in visible, disruptive ways. Even more curious is the role that underwater gas emissions could be playing in the formation of the Whirlpool. Volcanic activity beneath the ocean floor often releases large amounts of gas, primarily carbon dioxide, methane, and sulfur dioxide, into the surrounding waters. These gases reduce the water's density and can cause localized zones of buoyancy, essentially making certain regions of the sea lighter than others. When this imbalance occurs on a large enough scale, it has the potential to destabilize the vertical structure of the water column, causing warmer, lighter water to rise and cooler, denser water to sink in uneven, chaotic bursts. These movements can then become exaggerated by Coriolis forces, eventually spiraling outward into rotating vortexes. In this sense, the Whirlpool might not just be a symptom of heat displacement. It could be fueled in part by massive underwater gas releases tied directly to volcanic unrest. Adding another dimension to this theory is the possibility that the seafloor itself is undergoing a kind of tectonic resettling. While tectonic plate boundaries are typically thought of as slowly shifting zones, there are moments, especially after long periods of pressure accumulation, when a sudden realignment occurs. This can cause not only earthquakes but also a rapid reshaping of the terrain. If a large enough section of seabed were to suddenly drop, tilt, or uplift even a few meters, it could displace millions of tons of seawater almost instantaneously. Such a mass movement wouldn't generate a classic tsunami unless it reached the coastline, but it could certainly send shockwaves through the ocean, rippling outwards and spawning eddies, whirlpools, and strange current patterns that linger long after the initial event. And then there's the magnetism angle, an area of research still in its infancy, but one that is starting to attract more attention. Some of the underwater regions experiencing the most turbulence have also been noted to exhibit minor anomalies in the Earth's magnetic field. While the exact mechanism behind this is still being studied, it's believed that the movement of molten rock beneath the crust may be influencing the magnetic properties of the seafloor. These subtle magnetic shifts might seem irrelevant at first, but in the fluid, complex system that is the ocean, even small variations in magnetic alignment can interfere with compass-based navigation, disrupt marine life migration, and potentially even affect the way currents form and flow. The implications here are staggering. We may not be witnessing just a geological hiccup or a passing oceanic fluke. Instead, this could be the visible surface of a much larger, more dynamic transformation happening beneath us, one that's been slowly unfolding for years, largely hidden from human eyes. The Whirlpool, then, becomes more than just a swirling mass of water. It becomes a symbol, a messenger of sorts, pointing to deeper forces at play, forces that we are only beginning to understand, and which may be signaling a more widespread shift in our planet's internal rhythms. With each new data point, the pieces of this mystery continue to align, suggesting that we may be standing on the edge of a new understanding of submarine volcanism and its direct influence on surface ocean dynamics. This isn't just a fascinating oceanic event, It's a portal into the hidden systems of Earth itself, offering clues to how the most ancient, powerful forces on our planet can still surprise us, alter our environments, and reshape the natural world in dramatic and unforeseen ways. Now, let's talk about a more speculative, yet quite an intriguing idea. The possibility that this strange oceanic whirlpool is the result of an ancient, long-dormant artificial structure buried beneath the seafloor, one that may now be reactivating. As strange as it sounds, the idea that there could be remnants of long-lost advanced civilizations hidden deep beneath the ocean isn't entirely outside the bounds of scientific curiosity. In fact, over the past several decades, sonar scans and geological anomalies have revealed unusual geometric formations beneath the waves, structures that don't quite fit with natural patterns and formations. Some researchers have quietly suggested that these anomalies could be the eroded remains of ancient constructs, perhaps from a civilization that existed before recorded history and was lost to a cataclysmic event, like a rapid sea level rise or a massive asteroid impact. Now imagine this: one of those dormant remnants, resting for millennia beneath layers of sediment and rock, is beginning to stir, perhaps triggered by tectonic shifts, magnetic anomalies, or even rising temperatures that have slowly begun to compromise the bedrock around it. The energy required to create a whirlpool of this size, this intensity, has baffled experts. But what if it isn't a natural occurrence at all? What if it's the surface expression of a powerful subterranean mechanism beginning to hum back to life? Some scientists have quietly floated the idea that buried under certain parts of the Atlantic, particularly in regions tied to long-standing legends like the Bermuda Triangle or the mythical Atlantis, there could be remnants of massive energy systems, ancient reactors, or large-scale electromagnetic devices far beyond the capabilities of even modern engineering. These wouldn't necessarily be active in the traditional sense, but instead lying dormant, protected by fail-safes and ancient safeguards that are now slowly failing or responding to changes in environmental conditions. Now let's push this theory just a bit further while still keeping our feet in the realm of the just maybe. Consider the reports, largely dismissed at the time, of strange metallic readings picked up from sonar scans over the past few decades. These weren't your typical rock formations. Some were arranged in grid-like patterns or concentric circles, almost like massive underwater turbines or gates. At the time, these were chalked up to natural formations, but their alignment, symmetry, and reflectivity have continued to puzzle a few fringe researchers who never fully accepted the official explanations. Now, with the emergence of this whirlpool, right above one of those very grid points, those old data sets are being quietly re-examined. What if this isn't just a whirlpool, but a mechanical anomaly, a malfunctioning pressure release system, or even a power conduit beginning to leak energy upward, agitating the waters and creating a self-perpetuating vortex? The churning water could be the byproduct of a restart sequence, or a destabilized energy feedback loop that's using oceanic pressure gradients as its release valve. Even more eerie is the possibility that this event wasn't random at all. Some fringe thinkers have proposed that the Earth might periodically trigger these mechanisms as part of some ancient planetary maintenance system, designed not by aliens or gods, but by humans, or human-like beings, far older than we've ever dared imagine. These mechanisms might regulate magnetic fields, plate tectonics, or even global weather patterns, lying hidden until the Earth reached a critical threshold where their reactivation became necessary. Or worse, where a system failure caused them to spring to life, destabilized and unpredictable after millennia of slumber. The whirlpool, in this context, becomes something far more chilling than a natural anomaly. It may be a signal, a side effect of a buried system coming online, unaware or indifferent to the world that has changed above it. Its sudden appearance, growing force, and resistance to conventional explanations suggest that it's not a fluke of nature, but an artifact of intention, an engineered occurrence that we simply weren't meant to see until it was already too late. And if that's true, if this is a machine awakening after eons in silence, then the real question becomes, what happens next? Because if one mechanism is activating, how many more are out there, hidden beneath the oceans, sleeping, waiting? As we continue to unravel the possible outcomes of this bizarre and intensifying anomaly beneath the ocean's surface, we arrive at a deeply unsettling yet entirely plausible consequence: the disruption of global maritime navigation and commerce. At first glance, it may seem like a niche problem, the kind of issue confined to shipping magnates or logistics analysts. But the truth is far more far-reaching. The ocean is not just a vast body of water separating continents. It is the beating heart of global trade, the invisible highway upon which the modern world relies for virtually everything it consumes. From coffee beans to crude oil, microchips to medical equipment, the lifeblood of civilization moves across the sea. And when something threatens to disturb the rhythm of that flow, especially something as mysterious, growing, and uncontained as this massive underwater whirlpool, the potential for systemic collapse becomes very real, very fast. Picture this: an increasingly powerful circular current, fed by unknown forces, begins expanding in a crucial part of the Atlantic, quietly overtaking what was once a routine passageway for international shipping vessels. The whirlpool doesn't have to be instantly catastrophic to cause disruption. It only needs to instill enough fear, enough unpredictability, to begin pushing vessels off their typical paths. Ships begin reporting unusual magnetic interference, subtle changes in water pressure, or bizarre malfunctions in navigation instruments. These early reports get written off as isolated incidents at first, minor equipment failures, glitches, maybe a case of miscommunication. But as the weeks pass, the pattern becomes undeniable. More and more vessels experience inexplicable issues. A few disappear altogether, last seen drifting too close to the vortex's swirling edge before vanishing from radar. Whispers of something unnatural brewing beneath the surface start to grow louder, until shipping companies have no choice but to react. Major carriers begin rerouting traffic, at first slightly, adding a day or two to typical voyage times. But as the zone of danger continues to swell, the detours stretch into weeks. The cost of fuel, manpower, insurance, and cargo safety begins to climb rapidly. What used to be routine delivery timelines become unpredictable gambles, and the delicate balance of just-in-time supply chains begins to fracture. This doesn't just affect one region or industry, it sends shockwaves across the entire globe. Manufacturing slows as raw materials take longer to arrive. Retail shelves grow spotty as common goods become harder to source. Pharmaceutical supply chains are delayed, leading to gaps in medication availability in hospitals and clinics. And because everything in our interconnected economy is linked in a massive, invisible web, those delays compound upon one another until even consumers feel the pinch. Governments take notice, and so do the militaries of the world's superpowers. Surveillance drones, research vessels, and naval fleets are dispatched to the area in increasing numbers. But the strange interference persists. Instruments lose calibration. Communication blackouts become more common. Some unmanned vehicles go dark entirely, never returning any data. Military analysts begin raising red flags behind closed doors, not because they understand what's happening, but because they don't. The unknown is always more dangerous than the known. And so, amidst the chaos, whispers begin circulating in intelligence communities that this may be more than a geological event. Something ancient. Something dormant. Something reawakening. At the same time, global insurers begin reevaluating risk profiles. Major underwriters refuse to insure ships passing anywhere near the affected zone. Premiums skyrocket, and without insurance, cargo carriers pull their fleets further away. Port authorities begin seeing backlog build as incoming ships dwindle. Dock workers have fewer containers to unload. Exporters scramble for alternate routes or suffer massive financial losses due to delays and cancellations. What began as a curious phenomenon under the sea has now become a slow, grinding disruption to the gears of global commerce. And yet, the general public is largely unaware. The media, struggling to make sense of the scientific jargon and military silence, can only offer vague headlines about shipping delays and temporary rerouting caused by unusual oceanic conditions. But beneath the surface, quite literally and metaphorically, lies the creeping realization that this is no passing disturbance. The vortex, growing in size, energy, and mystery, has begun to exert its own gravitational pull, not just on the sea, but on the systems that keep modern society stable. And perhaps most chillingly, it's doing so in silence. There is no declaration, no explosion, no monster emerging from the depths, just an ever-widening circle of uncertainty and fear slowly claiming dominion over one of the busiest, most vital thoroughfares on Earth. In time, the world may be forced to adapt to this new reality. Strategic shipping alliances might break down under pressure. Countries that depend heavily on imports may face resource scarcities. Trade routes once considered permanent may be erased from maps altogether. And all of it because of something we still can't fully explain, something ancient, powerful, and now stirring beneath the waves. The ocean has always held secrets, but never one that threatened to rewrite the blueprint of civilization's very infrastructure. As we peel back the layers of this mysterious phenomenon, we are inevitably drawn into the realm of climate destabilization. The idea that an unknown force, one that seems to have a mind of its own, could alter the delicate balance of Earth's weather systems isn't just speculative. It could become the heart of the disaster that unfolds. If this strange underwater anomaly continues to grow, it could be affecting the world's atmospheric conditions in ways we can't yet fully grasp. The oceans and the atmosphere are locked in a constant, intricate exchange of energy. When something disrupts the ocean currents, as we're seeing now, the ripples don't just remain in the water, they reach up into the sky, into the very air we breathe. Imagine, for a moment, that this deep-sea anomaly is having an impact on atmospheric pressure systems, something scientists have only begun to speculate on. The swirling vortex, buried beneath the ocean's surface, could be contributing to dramatic shifts in weather patterns, creating new climate anomalies that seem to emerge out of nowhere. The cold currents that once stabilized weather along the coastlines are being shifted or distorted, and the temperate regions that once relied on predictable seasonal cycles are suddenly experiencing abrupt changes. Unseasonal storms begin to form, cyclones and hurricanes gather strength in areas where they were once rare, and regions accustomed to a calm, temperate climate are experiencing severe, out-of-nowhere weather. In cities and towns along the western seaboards of continents, temperatures begin to rise far beyond expected norms. Droughts stretch out longer, withering crops and drying rivers. What was once lush farmland is reduced to cracked earth, parched and barren. Farmers, unsure of whether to plant or wait, watch as their livelihoods begin to evaporate, unable to predict what the next season will bring. The threat of widespread crop failures looms large. Not just one or two varieties, but entire ecosystems of crops that depend on delicate, seasonal rhythms start to wither under the strain. As agriculture buckles, so too does the delicate balance of food supply, sending ripples through global markets. The cost of staple goods, once considered stable, climbs steadily until it becomes unaffordable for many, resulting in large-scale food insecurity. Meanwhile, on the opposite side of the world, coastal regions begin experiencing rising sea levels at an accelerated pace. The ice caps that have held their ground for millennia begin melting faster than scientists had predicted, likely due to the added heat from unpredictable oceanic currents. As these glaciers and ice sheets disintegrate more rapidly, large swaths of land that were once safe from rising seas are now threatened. What was once considered a minor problem, coastal flooding during high tides or storms, becomes a regular occurrence, and the damage intensifies with every passing year. Entire cities, once considered too far from the coastline to worry, now find themselves on the brink of sinking beneath the waves, as sea levels rise, seemingly without warning. The world begins grappling with a new kind of reality: coastal cities submerged, people displaced, and ecosystems destroyed at an unprecedented rate. Migration accelerates as millions of individuals are forced to leave homes they've inhabited for generations, seeking refuge in higher ground, further inland, or across international borders. On the other hand, the immediate impact on vulnerable ecosystems might be just as catastrophic. Imagine the devastating effects on marine life. Species that once thrived in stable temperatures begin to falter, and those that rely on specific currents to migrate are thrown off course. Fish stocks, vital for the global food supply, dwindle as entire schools of fish are disrupted by the unpredictable current patterns. Coral reefs, already suffering under the strain of rising ocean temperatures, suddenly face a new threat, one that disrupts the nutrient flow necessary for their survival. As the ocean turns more turbulent, these once thriving marine environments begin to collapse, contributing to a cascading series of failures that echo across both the natural world and the human world. The worst part, however, is that this disruption doesn't fit neatly into the categories we've become accustomed to. It isn't just a slow burn, where change is gradual enough to allow for planning and adaptation. Instead, it's a series of sudden shifts, a chaotic mess of extreme heat and rising waters, of shifting agricultural zones and unpredictable storms, creating a landscape that feels unfamiliar, even alien. The world that many of us grew up in, where weather patterns were predictable, where we knew the rhythm of the seasons, begins to unravel in a way that feels like a nightmare unfolding in real time. Without warning, entire nations are thrust into crisis. The time once spent debating whether we have enough time to act now becomes irrelevant. The action needed is immediate, and yet the solutions are unclear. Our infrastructure, designed for a world of predictability, simply can't keep up. The destabilization of the climate is no longer a future concern. It's here, embedded in the everyday weather patterns we now see around us, in the lives disrupted by floods, wildfires, and heat waves. What's more, the idea that we can somehow fix this problem by waiting for the next set of global climate accords or relying on slow, incremental change feels increasingly impossible. When the atmospheric conditions themselves are being bent and twisted by forces we can't even see, how can we hope to predict what the next year will bring? For the first time in human history, we may be looking at a world where nature itself is rewriting the rulebook of life. As this unprecedented phenomenon unfolds, we can also look ahead to the possibility of a global geopolitical shift. The cascading environmental effects, rising sea levels, shifting agricultural zones, and increasingly erratic weather patterns could lead to significant changes in global power dynamics. In the past, geopolitical stability has largely relied on fixed boundaries, reliable food sources, and predictable trade routes. But now, with critical infrastructure being wiped out by massive flooding, agricultural output collapsing in key regions, and populations displaced in alarming numbers, we may see nations rethink their strategies, alliances, and even borders in ways that could dramatically reshape the global landscape. Picture a future where nations that were once stable and self-sufficient are forced to grapple with the sudden and overwhelming pressure of mass migration. Imagine entire populations of island nations like those in the Pacific, whose homes are slowly but inevitably swallowed by rising seas. These nations, with no land to retreat to, are faced with the grim prospect of either vanishing into the ocean or becoming refugee populations themselves. As a result, entire regions of the world may be forced to either open their borders or face mass instability. The refugee crisis that has already been a point of concern in various parts of the world could now take on an entirely new dimension. Entire countries may be forced to accommodate millions of displaced individuals from nations once considered safe from such crises. The movement of people will no longer be a matter of seeking economic opportunity but of sheer survival. With no place left to go, these migrations could spark new tensions and even conflict as resources are stretched thin and nations struggle to cope with sudden population surges. What's even more unsettling is the potential breakdown of international cooperation. The world's reliance on organizations like the United Nations or regional coalitions to manage crises may quickly unravel. With each nation scrambling to deal with the immediate pressures of climate-related disaster, there is a risk that national interests will take precedence over global cooperation. The fragile alliances that have been built over decades could crumble under the weight of competing survival priorities. Countries with the resources to mitigate the worst of the damage may turn inward, hoarding food, technology, and vital infrastructure, leaving less developed nations to fend for themselves. As natural disasters become more frequent and severe, countries will be forced to prioritize their own people's safety, security, and livelihood above all else. The idea of global solidarity in facing shared environmental challenges might quickly become a distant memory. But it's not just about the outward pressures of migration and conflict. Nations are also likely to look at the emerging trends of resource scarcity, particularly when it comes to water and food. In a world where unpredictable weather patterns cause crops to fail and water supplies dwindle, countries may begin to vie for control over these increasingly valuable resources. Territories that once seemed insignificant, places like freshwater lakes or arable land, could become flashpoints for conflict. The scarcity of these resources could lead to a new kind of warfare, not fought with traditional weapons, but with economic sanctions, trade blockades, and the strategic hoarding of essential goods. The power of nations that control these resources, such as fresh water or fertile land, could see a dramatic rise as they become the linchpins of the global economy. Furthermore, the shifting climate might drive nations to look to new, previously unexplored regions in the hunt for resources. The polar regions, once locked under miles of ice, may become the next frontier. As the ice recedes, previously inaccessible territories rich in oil, gas, and rare minerals could open up. This could spark a new wave of international competition and tension as nations rush to stake their claims. In this scramble for resources, we could see the resurgence of colonial-like ambitions, where countries with the necessary military and economic might push into these new territories, sidelining international agreements on sovereignty and environmental protections. The scramble for the Arctic's vast untapped resources, coupled with the accelerated climate shift, could very well lead to increased militarization in these formerly untouched regions. There's also the looming danger of political instability within countries that are heavily impacted by these environmental changes. Nations that rely on specific sectors, such as agriculture, tourism, or fisheries, could see their entire economies collapse under the strain. A country like Brazil, for instance, with its vast agricultural output, may find itself unable to feed its own people as crops fail year after year. In such a scenario, governments may face unprecedented pressure to provide for their citizens, potentially leading to widespread civil unrest or even regime change. The ruling governments of affected nations might find themselves unable to control the mass exodus of people, or they might be overwhelmed by the mounting pressures of resource shortages. In a worst-case scenario, we might see countries devolve into chaos as political power structures fail to address the needs of the people, leading to the rise of radical movements or authoritarian regimes that promise quick fixes to mounting problems. On a global scale, the changes we're witnessing could lead to a shift in the overall balance of power. Historically, major global powers have risen through industrial might or military conquest, but the next great global struggles may be driven by the need to control the planet's dwindling resources. This new world order, shaped by climate-induced factors, could see a dramatic shift in who holds the most power. Nations with the foresight to invest in sustainable practices and resource management might emerge as leaders, while others, stuck in outdated systems of governance or reliant on outmoded technologies, could see their influence wane. The coming decades could reshape the geopolitical landscape in profound ways, potentially creating a new era of global competition not just over territory, but over survival itself. In this new reality, the strategies of the past may no longer hold relevance. The fight for resources will be less about military power and more about environmental resilience. Who can adapt? Who can survive? The answers to these questions will define the new world order, with countries either sinking into chaos or emerging as beacons of stability in a fractured, unpredictable global system. The need for innovative, cooperative solutions will be more critical than ever as we move into a world where survival depends on how well we understand and adapt to the new challenges posed by this global phenomenon. As we reflect on the myriad potential reasons behind the ongoing environmental shifts and their catastrophic consequences, it becomes clear that the situation we face is unprecedented in human history. What was once considered a distant and abstract threat is now a looming reality, one that promises to reshape every facet of our world, from the very geography beneath our feet to the political, economic, and social structures we have relied on for centuries. The scientific community has been ringing alarm bells for years, but only now, as these changes accelerate before our eyes, can we truly grasp the magnitude of what is unfolding. The initial cause we explored, the breakdown in ocean currents, particularly the disruption of the thermohaline circulation, reminds us of how interconnected the world's climate systems truly are. This delicate balance, when disrupted, sends shockwaves through every ecosystem, weather pattern, and agricultural system on Earth. As the oceans, once seen as an endless resource, begin to show signs of fatigue, we must confront the reality that we are at a critical juncture. The disruption of oceanic flows doesn't just affect marine life or coastal communities. It reverberates globally, altering weather patterns, impacting food production, and intensifying the risks of catastrophic flooding. As we come to terms with this shifting reality, we must acknowledge the profound challenges ahead. Whether it's the erratic and increasingly extreme weather, the diminishing of vital freshwater sources, or the creeping rise of sea levels, the world is facing the fallout of the environmental changes already set in motion. Then, we moved into the speculative territory, examining how a rapidly evolving world could be the result of extraterrestrial influences or other cosmic anomalies. While some of these theories might seem far-fetched, it is important to consider all possibilities, no matter how unconventional. Could there be an unseen, external factor triggering these shifts? Could cosmic events, such as solar flares or the unanticipated passage of an unknown asteroid, be affecting Earth's magnetosphere or influencing the delicate balance of our atmosphere in ways we are just beginning to understand? These ideas, while speculative, offer a lens through which we can challenge our assumptions about the stability of our planet and the forces that govern it. As we look to the future, it's clear that no theory should be dismissed outright, and each potential cause, be it natural or otherwise, deserves investigation. However, amid all of this uncertainty, one thing is certain: the effects of these global changes will not be limited to environmental degradation alone. We are already beginning to witness the early signs of geopolitical upheaval. Nations that once thought themselves insulated from such crises now find themselves scrambling to adapt, often reacting from a place of fear and survival. The scramble for resources, the sudden collapse of agricultural systems, and the increasing frequency of natural disasters are forcing governments to rethink their priorities. As people flood borders seeking safety from rising seas, famine, and drought, international tensions will undoubtedly rise. The threat of conflict over resources, especially fresh water, arable land, and vital infrastructure, will likely fuel divisions between nations, while displacement on a massive scale will test the limits of our compassion and cooperation. In this new world, we will need to come to terms with a harsh reality. Our survival may depend not just on how well we manage our resources, but on how well we learn to navigate a new geopolitical landscape defined not by economic power or military might, but by the ability to adapt to environmental shifts. Moreover, as the global power structure begins to shift, we cannot ignore the reality that some nations may thrive in this new world while others falter. Those with the foresight and resources to develop sustainable technologies, build resilient infrastructure, and protect vital ecosystems may emerge as the new powerhouses of the future. Meanwhile, nations that fail to invest in these critical areas may find themselves at the mercy of the very environmental forces they once ignored or dismissed. The future may not be a battle of military dominance, but rather one of technological and ecological superiority. Countries that learn to thrive in this new world, embracing renewable energy, sustainable farming, and resilient infrastructure, may come to define the future global order. Conversely, those that ignore or delay action may find themselves scrambling to catch up, their political stability increasingly threatened by the very forces they once thought they could control. Finally, as we look ahead to the potential long-term effects, we must also grapple with the notion that these changes may not be reversible. The environmental damage that has already been done, whether through the unchecked burning of fossil fuels, deforestation, or the poisoning of our oceans, may have passed a point of no return. As the systems that once sustained life on Earth begin to break down, we are faced with the grim reality that recovery, if it is even possible, will be a process that takes generations, if not centuries. We may be living in the dawn of a new era, one where humanity is no longer in control of the planet's destiny, but must learn to adapt to the rapidly shifting conditions that nature imposes. What is clear, however, is that this crisis, no matter its cause, demands our immediate attention and action. It will not be enough to continue on with business as usual, hoping that these forces will pass or be mitigated in time. The window for meaningful change is rapidly closing, and the decisions we make now will shape the future of our planet for generations to come. From the technological innovations we embrace to the policies we adopt, every action will ripple outward, influencing the trajectory of our species and the world we inhabit. The road ahead may be fraught with challenges and uncertainty, but it is also a time for unprecedented collaboration, innovation, and resilience. As we stand at the precipice of this new reality, we must recognize the interconnectedness of our world and the urgency with which we must act. Whether it's through cutting-edge science, bold political action, or the development of sustainable solutions, we hold the power to steer this crisis toward a future of adaptation and survival. Yet, it is only through collective action, through a shared commitment to a more sustainable and equitable future, that we can hope to mitigate the worst effects of these changes and create a world where future generations can thrive. The time to act is now, and the course we choose today will define the future of humanity itself. If you've found this video insightful, make sure to hit that like button and subscribe to the channel for more deep dives into the issues shaping our world. Your support helps us keep bringing you valuable content. Thanks for watching.